Hi friends, now we are going to discuss the most important topic of the chapter, that is friction. It is 5.10. It's a friction. Already in previous topic we defined force of friction. The parallel to the surface. The force which is parallel to the surface in contact is called as force of friction. The force which is perpendicular to the surface is known as normal reaction. So, it is parallel. There are two types of frictions. One is called as static friction and one is called as kinetic friction. Third is also there, which is a rolling friction, but that we are not going to discuss in this part. Consider one block. This is block kept on this surface. Now, we know it is a body of mass m at rest on the table on any surface. Let's see the forces. Let us try to analyze the forces. One is force mg, which is also known as weight. Another one is reaction R. So R and mg, they are equal and opposite. Weight and normal reaction equal and opposite. Therefore, no net force on vertical direction. It is at rest. It means that there is no force along parallel direction of the surface also. And therefore it is 0, no force. Now let us apply force in this direction. Let us pull this block in this direction. Slight force. We apply a slight force. Then the block is not moving. It remains at a rest position. What does it mean? The applied force is here. Block is not moving. There is equal and opposite force in this direction. Then we increase applied force slightly. Again block is not moving. It also again indicates that the force along this direction also increases. So block remains stationary even though we apply certain force. And then there is a force developed in this direction which is called as static force of friction. We call this thing as static force of friction. Fs. Fs maximum is equal to mu s n. Fs maximum is equal to mu s n, or Fs is directly proportional to the normal reaction. This is the law of static friction. Force of static friction is directly proportional to normal reaction. So again, force of static friction is equal or less. This mu s is called as coefficient of static friction. Mu s is known as coefficient of static friction. It will never, as soon as this one, this becomes more, it starts moving. So it is the force responsible to keep it stationary. It opposes. It is called as impending motion. What is the meaning of impending motion? Impending motion is the motion which actually does not take place but which would take place in absence of friction. Motion pending because of this force of friction. So this is the important law. Force of static friction is directly proportional to normal reaction. It is the maximum force of static friction is equal to mu s n. It is equal, it is maximum or less than this one. So it comes in this form. Mu s is known as coefficient of static friction. That is, it is independent of area, independent. Area of contact. That is important. The force of static friction is independent of area of contact. It depends only upon nature of the surfaces in contact. This is only dependent on nature of surfaces in contact. Now, as long as this is also self-adjusting, as F increases, applied force increases, force of static friction is also increasing. Then at one particular level, when this goes, then the block will start sliding, it will start moving. And when it started, that is called as kinetic friction. When the block moves, thereafter, once it is in relative motion, it is not the motion but relative motion, then it becomes a kinetic friction. Kinetic friction is obviously less than Fs. Fk is less than Fs. But rule for kinetic friction again, Fk is directly proportional to normal reaction. Fk is equal to mu k n. This is called as coefficient of kinetic friction. This is again independent of area. Kinetic friction depends upon the nature of the substance in surfaces in contact. It is independent of velocity of the body. It is also not dependent of velocity of the body. This is the kinetic friction. Now, kinetic friction, if you check it, it is when the body starts moving. It means that applied force is here. Kinetic friction, you can take it in this way. When it starts moving, this is applied force. In this direction, it is kinetic. So net force is F minus Fk, through which it is accelerated. Body is accelerated, m into t. Now F is made 0, then Fk is equal to ma. It becomes a negative acceleration. As soon as applied force is made 0, then the body decelerates because of this kinetic friction. It becomes 0. So Fk, or this is deceleration. So kinetic friction is, alone kinetic friction will resist the motion of the body. So when applied force and kinetic friction both are equal, then they move with a uniform velocity. So relative motion is important in this one. For example, there is a block. This is the train moving. If the train is moving and one box is kept on the floor of the bogie. Now this box is also accelerated with the acceleration of train. Then which force is acting on this box? Nobody is applying force there. Now let us think in this way. For a time being, this box is there is no friction between the surface of the block and the surface of the bogie. Then the box will just move in backward direction and will be stopped by this side of the bogie. It means that the box is accelerated because of friction between train and the surface of the bogie and surface of the box. This is very important thing. Whenever friction is absent, box will move in opposite direction and will be stopped by this side of the bogie. These are important things in case of kinetic frictions. Now let us discuss some problems based on this kinetic friction, and these are solved problems. These problems are solved problems.